Hey guys, Miss Morell here to demonstrate how to make a topographic map out of a potato. Looked for one on YouTube, but couldn't find one I really liked, so I decided to make my own. So I am filming this looking through my camera while cutting things with sharp objects, so let's hope I don't cut my fingers off. So if you're in class, we've given you a bag of sliced potatoes. But if you're at home doing this, then you're going to have to slice your own potato. So if you need to get a parent to assist, please do so. The first thing I'm going to do is I'm going to go ahead and cut off one end of the potato. So I'm cutting it at the widest part of the potato. So this was the widest part. And I'm just going to set that other side away because I need the widest part to be the base of my potato mountain. And then I'm going to make a line all the way down from the top to the bottom of my potato. And that line is just going to help me be able to line up my slices once I'm making my map. All right, so now I'm just going to make some slices. I'm going to go for 3 slices, 3 cuts. That would give me 4 slices of potato, and hope that that is enough of a difference in size slice so it's easy to draw and see on the paper. So here it goes. Let's start slicing. All right, watch out for fingers, Amy. All right, here we go. 1, 2, 3. So now I have 3 cuts and 4 pieces of potato. Now, I've gone through several potatoes at my house this morning while I've been doing this. And one thing I've learned is that I need to dry the potatoes before I start putting them on the paper to draw the map, because water leaches out and then the paper underneath your potato gets really messy and gross and you can't really draw contour lines on it. So hopefully you guys kind of remember this from last year. We talked about it at the end of the year. Topographic maps are a way to show the 3-dimensional features of land, the topography, in a 2-dimensional form. We've been talking a lot about crustal features lately, the landforms that are created at plate boundaries. We've learned there are 3 types of boundaries. The transform boundary, which can cause earthquakes and destruction. A divergent boundary that can cause underwater volcanoes and mountain chains to form, and on land it can cause rift valleys. And then convergent boundaries that can form mountains, volcanoes, and ocean trenches. So I feel like that should be dry enough. All right, so we're going to start with our biggest piece of potato, and I'm going to leave these sitting on the paper towel so that they continue to soak up water. So we're going to start with the biggest piece of potato, which is right here. I'm going to find the line, and I'm going to put it toward me. I'm going to set the potato down on the paper, and I'm going to trace all the way around the base using a black marker. And I can't really move to see very well because then the camera moves, because I'm using Adam's funny little camera holder, but you get the idea. All right, and remember, the line was facing toward me. It's right there. So now I can set that piece of potato aside and get the next biggest piece of potato. And it is right here. So I'm going to face the line toward me, and I'm going to place it inside, centered, where the other potato slice was. And there's not going to be a whole lot of difference in the diameter of these 2 pieces, but you will be able to see there is a difference. So the bottom layer is wider. So then as we go up in elevation, it's becoming narrower. So I've got 2 layers now. So now this one hopefully should be actually really nice and visible. I'm going to turn it this way so we get an even smaller layer. And there's my line pointed right at me. So now I'm going to draw all the way around there. So there's my next layer. Oh, good. Now I can definitely see the layers. And then I have one more layer to go. Oh, but there's not much difference at all in that one. So real quick, I'm going to make an extra cut here so that I can find the line. And then I'm going to use the narrow side of that so that I can trace around it and hopefully be able to see a difference in elevation. Okay. Oh, that looks nice. Awesome. While we're at it, we could do that again. I've got a little piece left here, so I'm going to use the knife and cut this little piece, and I'm going to use the top to show the top of my mountain. And then we'll put all the potato pieces back together in a second so you can see. All right, so now I'm going to trace this. Whoops, that's what happens when I can't really see what I'm doing. Okay. So there's my top piece. All right, excellent. So now I have several what are called contour lines. And if you'll remember, contour lines are simply lines of equal elevation on a map, on a topographic map. Every contour line is exactly the same elevation. All right, so I'm really bad at puzzles. I need to put this potato back together. So we're just gonna kind of eyeball it. And there, and there, and there. So, well, hang on. Yep, that's right. Okay, so I've put my potato back together so you can see there's the line I drew down the side. So you can see from the side, that's what my potato looks like. So I've shown these slices, these contour lines. I traced around each one on the paper. So this is the base. And as the lines go up, the elevation increases. So if we said that this potato mountain is 500 meters tall, I have 1, 2, 3, 4, 5 layers of potato. That means each layer is 100 meters. So the outermost will be 0. The second would be 100. The third would be 200, then 300, then 400, then 500 at the top. So there, hopefully now you know how to make a topographic map out of a potato.